Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today we're starting new playlist, Kinematics two-dimensional now. And two-dimensional kinematics that we will be talking about, we will be always throwing some body under the angle. It may be a ball, it may be a projectile, it may be a cannonball, it may be a rock, anything that flies, and it flies with initial speed v0 and it flies under angle alpha. And we will be solving all kinds of problems about this. So I can call it a cannonball, a baseball, a basketball, or just a body that's flying with initial speed v0 and the angle alpha. And the essence of this problem, all of them, is that we say that there are two directions, y and x. And it would be always like this, y and x. And we will say that in this direction there is always will be acceleration g. And in this direction there would be nothing. Of course, when we fly something, there is always air resistance, depending on the shape of the body, if it's a small body, if it's a big body, if it's a big surface, with a lot of drag and stuff like that. But we will ignore it. In all those problems, the air resistance is ignored. So, when we will be talking about this, we will say that the body will start this movement with initial speed. So we say, if this, remember the playlist vectors? So we say if there is a vector v0 and if there is alpha, then we will have two projections. This would be v0x and this would be v0y. And this projection v0x would be v0 cosine alpha, and v0y would be v0 sine alpha. So we will say that the body that travels from here, and it's always x and y, always would be going from here, from the point where they throw it from. So this would be y, and this would be x. And we say that along x, this would be the movement with a constant speed, and this constant speed would be v0 cosine alpha. And that's it. And along y, there would be constant acceleration. Initial speed would be v0 sine alpha, and plus acceleration would be minus g. And that's all. So there would be two independent movements. Of course, as the body goes this way, it also goes this way, and then it starts falling, and when it would be here, it arrives somewhere here. So, as the body moves here, it goes up, so it's somewhere here. If the body comes here, it's somewhere here. If the body here and it starts falling, it's somewhere here. So it would be this thing that's called trajectory. And this would be trajectory of the body. And we will solve many problems attacking this from different angles, no pun intended, no connection to this alpha. But the first one, we will say a physical problem. They give us in this problem v0 equal 10 meter per second, and they give us alpha equals 30 degrees, and they want us to find the maximum height. And so height is related only to this motion. Height is not related to this motion at all. So this is motion with g, with initial speed. So we can say h equal, and we can write initial speed v0 sine alpha, this is initial speed in this direction, multiplied by t minus gt squared over 2. This is the first formula that we can write. And another formula that we can write is h equal v final squared minus v initial squared divided over, and acceleration is negative, so again, like here I put minus here. And this formula is easier because they give us initial speed. So we say when the body reaches the highest point, h, then speed in this direction is 0 minus, and initial speed in this direction was v0 sine alpha. And all of this has to be squared, because v0 sine alpha was initial speed in this direction. And of course, don't forget, minus 2g. And h equals v0 squared sine squared alpha divided over 2g. Minus and minus gone, 2g is known, and so now everything is known. v0 was 10, alpha is 13. So we can say h equal 10 multiplied by 10 will be 10 squared. Sine of 30 is 1/2. You can check calculator, but I know that it is 1/2. So it is 1/2 squared. And you can refer to trigonometry playlist. There is like a special clip about those special angles. And divided over 2, and g, of course, I will write 10, but your teacher probably will like 9.8, but forgive me. So then we have 1, 2 is 1, 4, which would be 120, and 4 will go to the bottom, right? So v0 is 10, 10 squared this, 1/2 sine alpha, 2g, 2 by 10, 100, 2, and 4. It would be 4 meters. So it would be only 125 meter. Because it's like we're starting with the speed v0 sine alpha, so 5 meters per second. We're going up 5 meters per second. And of course, with 5 meters per second, we don't go too high, because in 1 second, the speed will be reduced to -5, because v0, remember, v equal v0 minus gt. If t is 1 second, it would be -10, and the vertical speed would be 5 minus 10, it would be negative. So we don't go very high, and we reach only 5/4, 5/4 of the meter. So the moral of this story is that it is vertical motion that determines the height of our flight. Vertical motion. And as we fly up, we also move to the side. So we climb a little bit and we move to the side. So our trajectory would be like that. And of course everyone knows, because if you throw something, it flies like that. Next problem would be similar, but a little bit continuation of this. So if you want to hear when I publish it, subscribe, bell, if you liked it, like, if you didn't like, don't like, comment if you have, question if you have, problem if you have. See you next time. Thank you.